So we've already seen other sorting algorithms, but here's another one. It's a little bit more complicated than, kind of more complicated than the other ones we've looked at, but it's really not too bad. But it's built around these two very basic ideas. The first one is an empty list and a list with just one thing in it is a sorted list. Despite the fact that it's an empty list or there's only one thing there, it's still sorted. All the elements in that list are in their proper location. The second idea is if we took this like number, let's just say like an arbitrary number in our list that we'll call the pivot, and we put all the numbers that are less than it over here and all the numbers that are greater than it over here. And if all the numbers that were less than this pivot were sorted in their list, so we've got a sorted list of numbers less than this pivot, my head, and we've got a sorted list of numbers bigger than the pivot over here, if I were to take this sorted list, put my head next to it, and then this sorted list, put my head here, then what are we left with? Another sorted list. So with these two basic ideas, we get Quicksort. So here's some code for Quicksort, and there are a lot of ways to actually implement Quicksort, but let's just look at the function Quicksort here. What does it say? So ignore this print and import for now, and we just say, okay, if the list that we're performing Quicksort on is empty, then we're done. We return the sorted list, we're done. If it's not, we pick a pivot, which happens to be the first element in this list. It can be any number. And then we partition the list. Basically what we're saying is put all the numbers less over here, all the numbers greater over here, and then put all the numbers equal to the pivot in another list called equal. So we've got less, equal, and greater. Then we sort all the numbers that are less than, and then we sort all the numbers greater than. But you don't need to worry about how we're sorting those less than or greater than. That's not really my problem. They're just going to get sorted. And then once we're done sorting, we just do that thing where we take this, and go like this, and we return the result. So that's what's going on here. We're quick sorting the less, then concatenating equals, then concatenating the greater than. The trick is, every single time we're partitioning, we're making the list smaller and smaller until we get to the point where the list is empty or has like one element in it. In our case, it's written in a way that the base case is only an empty list, but it can also be written in a way where the base case is a list that only has one element in it as well. So the list keeps getting smaller and smaller every time we partition, every time we make these recursive calls. And then once we get down to the bottom where we're left with just empty lists, we can start taking those lists and putting them together to build all the way back up to a fully sorted list. Now this chunk of code right here, partition, that's the magic code that's doing the partition. Take your time, go through it, make sure it makes sense. It's not too bad. But that's basically it. It's actually kind of a clever algorithm.